It looks like the humanoid robot will be the ultimate deployment vector for AGI. A lot of cases we're running the robots almost all day, and they're performing like useful work. So like you're starting to see signs that like this is actually going to happen now, and we're in the right decade. For me, like it's like the ultimate meta problem is like trying to solve humanoid robots. So like you have to just go right at it. So like, but now we have like electric systems that are like, I would say safe and, like reliable, kind of like heading down that trend, I guess. And then the second thing I think is we have like robotics is really like a neural net problem in the limit. And we really haven't seen neural nets do well in robots, until recently, almost like the last several years. So we have like, we now have neural nets running on board robot that are commanding, basically hand positions, head, torso, like basically the whole basically action space of the robot. And it's working really well. Like you're watching, you can watch some updates from us and you see we put an update out like a week ago or so of a robot just doing 60 minutes of like continuous logistics work. That was a single like S1 Helix neural net that we're running on board the robot. And it's just like, it looks like what a human would do in some way, like almost like imitating like very similar characteristics of what a human would have. And, we're approaching like human speed and performance of that robot. So that's also something I would say 5 or 10 years ago you just didn't have. So in the case of robots, we have like neural nets working, and I think hardware is getting like more and more capable in general, which is like kind of the two big inputs you really need to make this work.
Yeah, I'm curious about this. I don't know all the historical perspective on Figure, but was the intent always to like jump straight to humanoids, or like was there? And I think about this through the context of I just got a Matic home vacuum cleaner robot, and it's like materially better than any of the other robotic vacuums that I've tried in the past, and like it feels like very close to this sort of future of what you might imagine home robots looks like, but it's like obviously vastly different than a humanoid robot. It's super limited in what it can do, et cetera. So I'm curious, like sort of your headspace as far as like the path to make humanoids work. And obviously you all have taken the approach of like go straight to humanoids.
Yeah, I went straight to humanoids day zero. I wrote like a master plan, like basically like a vision doc. That's on the website now. The first day I incorporated with Delaware, I wrote that and put it out. So I wrote it the first day I started the company, and for me, like it's like the ultimate meta problem is like trying to solve humanoid robots. So like you have to just go right at it. Like there's some other options of like putting wheels and other type of end effectors like claws and other things in the robot, and it's basically a local maximum. Like it'll basically be like it'll be a significant issue trying to get to where you really need to go if you're not designing straight for like the right system from day one. It's basically going to act like a huge crutch for the business. So I thought like my thesis like 3 years ago was that it was possible to go do this, and so we basically like started just building and designing humanoids from day one at the company.
Yeah. One really quick follow-up on this, and then sorry, Nolan. I'm just like part of the Tesla master plan was around like, they needed to do a bunch of stuff to actually like fund making that happen. And obviously the fundraising climate right now in 2025, very positive towards AI, very positive towards robotics. But do you have a sense of like, over the last few years, like obviously that it's been like exponentially more interest, like lots more money flowing to this problem. But like, what were some of the early like points of conviction, like as you were actually putting this together, that like this was possible to actually go and build in that direction relative to like, again, going and, incrementally making your way there, doing something smaller, and then eventually getting to a humanoid?
Yeah. Okay. I have like somewhat of a interesting story. Previously, before founding Figure, I founded Archer Aviation in 2018. And, prior to that, I had an exit. I sold a company for a little over $100 million in the software space. So I had a little bit of money, started going and building like Archer, like with this conviction, like electric aircraft is both possible and like needed right now, and like a solvable problem. And the funding environment was just like non-existent for deep tech. Like there was just like, there was early investors were not funding like Tesla and Rivian and SpaceX, like those type of groups. Same for Archer. I put in like basically went all in on like my entire like basically like liquid net worth into Archer, but it wasn't. But I still needed like a lot of capital just to pull it off. It wasn't like I didn't have enough like net worth to make it significant enough. And I remember how just difficult the climate was for that at that point. And man, had things like it's what has that been now? Like 7 years. Like man, the whole like climate towards like deep tech has really flipped. Last like there's like fully dedicated funds for this. Like people realize now that like probably some of these deep tech companies might be the biggest businesses in the world or starting to become the biggest business in the world. So yeah, so I would say like when I started Figure, I basically also had a kind of a step up in net worth and was able to fund the business materially kind of from the get-go. So like right out of the gate, self-funded the company. I think we hit like $1 million a month in burn like month 5. And we were just like hell bent on like, let's just go build a humanoid. Let's get out there. Like let's make as much progress. We were walking a humanoid robot that we basically majority designed from scratch within like under 12 months from when we incorporated the company. So I would say it happened. I would say it happened really fast. And now we're in an environment where it looks like the humanoid robot will be the ultimate deployment vector for AGI. Like if you want things done in the physical world, it's like you're gonna have a hard time putting it on a vacuum cleaner or anything else. Like you really want like the AI on board a very high dimensional robot to be able to do work. So we're seeing kind of this emergence of like robotics and AI, which is like I would say like it's there's certainly a lot of capital I would say coming into the market in this area because of these trends. And I think beyond all that though, like the robots are working. Like we are seeing the robots starting to do like really useful like work. We can run the robot for in a lot of cases we're running the robots almost all day. And they're performing like useful work. So like you're starting to see signs that like this is actually going to happen now, and we're in the right decade, which is helpful as well.
But I think touching on the kind of transition from software to hardware, I'm always kind of curious to hear, as you made that transition, what challenges kind of take place in hardware that you weren't seeing in software? How do you address them? But also, from an adoption perspective, my intuition is that it's a lot harder to get folks to adopt hardware than it is software, especially with so much software coming out. People can go online, try it out if they like it, maybe become a user. If not, go on to the next thing. Like, how do you envision, and it's kind of a two-part question. So again, first and foremost, challenges in general, and then kind of the challenges around adoption as well.
Yeah, I mean, listen, there's a lot to talk about here. I think a few things, maybe I'll just like a few observations for me is there's on the hardware like side for an entrepreneur, it looks a lot like software, like in the limit with 10x, 100x longer timescales. So like like a lot of some upfront planning, and then saying like, okay, we want to go test this, we want to go do it. Like you go design it, you go build it, you then buy things in the supply chain, you bring it in, you early test it, you manufacture it, put it all together, and you see if it works. And like in some cases that took a year that you could do in like maybe days or weeks in software. But there's a lot of this, like I would say, a lot of similarities on. We have this underlying like scientific method hypothesis that we want to go test. It's backed by some like real early say customer feedback or some type of other like input, and we're going off and building something. We're going to try to see if it ultimately works, and then continue to iterate from there. The problems now is like you have like very long timelines. You have like very expensive things. You have to actually buy hardware now instead of just just writing software. And then hardware is just like tough to get out the door. It's like hard to make things actually work once you do it, because you have to make a lot more of that stuff. Or digitally, you can just infinitely scale software in SaaS or whatever to go scale it. So it's just like it's like software. It's like a death gauntlet for software entrepreneurs. it's like software entrepreneurship on steroids. It's just like really quite difficult. So, but but I think it's like really rewarding. And I think the one thing I had in my software days is I never felt like really rewarded. Like in software, I couldn't like feel it and touch it. And when we would show the product, you have to like log into like some browser and go show it. Just like it's something that like there's something really special about like physically building things in the world. And we spend so much time in a physical world. Like there's so in some way it doesn't get a lot of attention versus software like last 10 or 20 years. So I grew up around a lot of hardware, grew up on a farm, grew up building things. And I just really like after kind of my software days, I was like, I really wanted to get into hardware, like basically full steam. And that kind of led me into Archer and now Figure and Cover and the rest of my companies. And and it's been great. Yeah, adoption's harder. Everything's just harder. So it's I would say like software, but like just like turn the knob on like the challenges and difficulty to 11, and then you're here. But the one thing I will say though is that like I'm always like pretty anxious internally about making sure I'm designing for the right thing and heading in the right direction. And in some ways, like software, you really quite don't know because you're building something, you're getting it out, you're getting early like feedback and testing for users. You're not unclear if you like if this is going to work. In hardware, if we have this conviction, like okay, we should be flying aircraft instead of driving, like that's for sure going to work, and we can save people time. Or like say building tunnels underground. If you can like build that and make it cheap, that'll for sure work if you can engineer the right product. And the engineering is like relatively straightforward in terms of like making sure that like this is possible stuff to go do. It's like good first order engineering. We have to like it needs to be done on a clean sheet, but it's physics and there's rules around this. So in some way for me, it's been like the least stressful years of my career as an entrepreneur, like building hardware, because we have a rule book with physics that we can basically, basically axiomatically attribute back to. And I actually really enjoy it. Like I just, my life as a hardware entrepreneur has been both challenging and enjoyable. And, I like both those areas.
Quick follow up on that too, kind of around the adoption piece. As a team, how do you guys evaluate, who potentially would be the best fit, whether it's an industry? I know obviously you guys are heavy in manufacturing, heavy in logistics right now. Like, how are you guys kind of envisioning as you continue to roll out? Like, is it just kind of waiting to hear from folks like, hey, we think we can incorporate some kind of humanoid robot here? Do you guys have like a list of, 10 industries, 10 personas that you kind of want to go and kind of introduce this to? Just kind of curious to hear how you envision all that.
Yeah, at Figure, we have like two like focuses. We have a focus on shipping robots in the home, which is like a very unstructured, high variability environment. So home's like really hard. And then we have a focus on the workforce, like getting robots out to do logistics, manufacturing, healthcare, construction. It's kind of funny because the home is so much harder than the workforce. You would think that if you crack the home, it's like 1,000 times bigger market than the workforce because the difficulty, like the engineering difficulty is just so enormous. But it's actually like it's flipped. Like the workforce is half a GDP. It's much lower variability. Like I say this because like the engineering challenge is proportional to variability. So like if at least like lower variability is going to be easier to like integrate autonomous systems into, and you have that like, in most cases in the workforce versus the home. Like if you have to overall generalize to this, so the home is like, and then beyond that in the home, you can probably charge like an order of magnitude more in costs in the workforce in the home. Like the home, you got to build a robot and charge like hundreds of dollars a month too, right? Like in the workforce, like you have enormous ability to make a lot of money, and it's half a GDP. So we kind of focused on those like, basically two tracks. And then, the reality is we're trying to build a general purpose robot. So we want to be able to sign up clients and be able to do theoretically most things a human can inside their facility. So as long as the robot has the range of motion and the payloads and speeds to do it, like we should be able to do all that work. When we signed our like last logistics company, it's funny enough, it wasn't like we looked at that and said like, oh, we like the robot would be great at packages. Let's go after packages and go do it. We said we want to go after a place we can really scale into. We think logistics would be in this industry. We signed up the client. We had no clue what we were going to go do. We walked in at a bunch of facility tours. We found out like small package logistics is like a big part of the operations. They're having a really hard time hiring, hard time on labor, things like that. And we looked at that problem and said, oh my God, like every package is different. They're like poly bags. So they're moving when you're grabbing them. The pile up is different every single time. This is like, just like impossible to code your way out of this problem. Like this has got to be learned. And so we started like down the learn path. Like this has got to be like almost like, I got to go all in on learning for this. We went all in on learning, and right away we were like seeing it working, which was like, I think like really helpful. And now you're seeing some stuff we're putting out. And it's like it's hard to say. It's literally getting better every day now. So put the video out. We're doing like a package every 4 seconds. I saw it Friday. We're doing a package every 3.5 seconds. And we didn't actually clock it yesterday when I was like there sitting at it, but I swear that thing was like so much faster, and it was handling different types of variety of packages much better. It was doing really smart things like moving a package out of the way so it can push another package down the line, and then dealing with like the barcode and flipping the package after that, like almost like really thoughtful, like a chain of thought reasoning the robot was going through to do. So yeah, I think like, at a high level, we're trying to go down those industries. We're trying to like general purpose behaviors out of the robot from a learning perspective. And then we want the hardware to be able to do most things a human can. And we need like, we got to be able to do everything. So like, we probably want to start our view is like we're gonna like bootstrap this within a jumpstart this in the workforce right now, and then the home is coming. Like the home is like single digit years away from being able to really I think put robots in and be able to do like real useful work for humans autonomously. So we're pushing on that track also as hard as possible. It's just like it's very unstructured and different in every home we go into. So it's a little bit of a harder problem.